Number 7 here is an object starts from a position with initial velocity, has constant acceleration, and after 5 seconds it has a new velocity. What's the position of the object at 10 times 5 seconds? Give your answer in IJ notation. So the key here is it is constant acceleration. Okay. We don't know what exactly that acceleration is, but we can calculate that and then use constant acceleration equations in x and y independently to get our final position. So let's look at the two directions independently. So I start with x here. I have my initial velocity in x is minus 3 meters per second. My initial x is 13. Okay. And then at time equals 5, I have a new velocity. So delta t is equal to 5, and velocity x after 5 seconds is equal to minus 3 again. Meters per second. So, may be obvious, but let's write it out. So the velocity at x after 5 seconds is equal to velocity x0 plus acceleration at x times time. Okay, we have minus 3 equals minus 3 plus a sub x times 5. There is no acceleration in the x direction, just 0. Alright, so it's actually constant velocity in the x direction. So I can apply my equation for x. And we already said that was 0. So my position in x after 5 seconds was my initial x of 13 plus my velocity of minus 3 times 5. Alright, and that looks like that's going to be minus 2 meters. Alright, let's look at y direction over here. My velocity in y initially is 18. My position that I start at is, oops, that's my position, 18 meters. My velocity is 4. Positive 4 meters per second. Okay, and then my velocity in y after 5 seconds was a minus 7 meters per second. We use the same sort of approach as this one right up here, only use y values. So my final y velocity is minus 7. It's equal to my initial y velocity of 4 plus acceleration in y times my time. So acceleration in y is going to be minus 11/5. Looks like. Let's see. Minus 7 minus 4 is 11 divided by 5. Okay, so it's a minus 2.2 meters per second squared. Alright, and again we can do the same equation in y. Y equals y0, vy0t, 1/2 ayt squared. Okay, running out of room here. I didn't plan ahead very well, but my y value is going to be equal to y0 of 18 plus vy0 of 4 times 5 plus 1/2 acceleration y minus 2.2 times time squared. Okay, that gives me a y value of 18 plus 4 times 5 plus 0.5 times minus 2.2 times 5 squared. It's 10.5 meters. Alright, so there's my answer. I have in ij notation, I have my x value minus 2, I, my y value 10.5 j, and that is a position in meters.